so we've been looking at trig equations, but we've just been doing like our opposite operation. Today we're gonna do like another step further, and we're gonna look at factoring trig equations in order to solve them. So the first kind that we can see are going to be equations of quadratic type. Basically that means that we are able to rewrite it as like something squared plus that same thing minus or plus a constant, and it's set equal to 0. And that a, right, is like, normally for us it's been a variable, but we can also see it as like a sine or a cosine. So if I have something that looks like that, I still have a quadratic there, even though my variable, okay, or what's acting like my variable is cosine this time instead. And so remember, with our trinomials, so when we have 3 terms, we're going to factor that first, and then we make like 2 little equations with each of our factors now instead. So let's look at an example of that. So we have 2 sine squared minus sine minus 1 equals 0. So we did do some factoring when we looked at our trig identities. So remember, kind of an easy way to do it is just to come over to the side and pretend that our trig function is like some other variable. Because then it just makes it a little bit easier for us to try and factor. So what would we do then if I wanted to factor that? Yeah, our AC method. So I have 2 times -1 gives us -2. So what multiplies together to give us -2? That adds together to give us -1. -2 and 1. And then remember, we use those numbers to break apart our middle term. Then what do we do? How do we get our 2 factors from that?
Put parentheses on one side and the other side.
Yeah, we made 2 groups now. So what does our first 2 have in common? 2a. And I'm left with an a minus 1. What does our second 2 have in common? Just a 1. And I'm also left with a minus 1. Which is helpful because now hopefully we can see that our 2 parentheses are the same. And remember, that means that I can pull that parentheses out, and whatever is left goes in our second parentheses. However, for our equation, we don't have a's, we don't have x's, we have signs. Okay? Now, notice that a lot of people, when they start seeing these, their automatic response is to want to like add 1 and try and like take a square root of stuff, okay? But notice that I can't do that because I have this extra sign in the middle. So that's why we have to factor it before we can start doing our opposite operations. So we have sine of x minus 1 times 2 sine of x plus 1. Now, once I have it factored, remember that I can set each of those factors equal to 0, and we create like 2 little equations now that we can do our opposite operations with, like we've been doing. So how do I get my sign by itself on the first one? Add 1. How do I get my sign by itself on the second one?
Subtract 1 and divide by 2.
Cool. Now, is 1 a value on my unit circle? Yes? Okay. So remind me, our ordered pairs represent what on our unit circle? Yeah, cosine and then sine. So we're looking for where our y value is 1. So where would our y value be 1? Pi over 2. Now notice that we only get one answer this time because at 3 pi over 2, it is a 1, but it's a negative 1. So remember, when we're on our quadrants, those are the one time that we might not get 2 answers. We just get 1 answer in this case. Okay, so the next step we're looking at where our sine equals 1/2. So again, I'm looking at y values. So I need a y value of 1/2. Yes? And remember, that's going to be from our first ordered pair, which is 30 degrees or pi over 6. Yes? But sine is positive at pi over 6, and we need a negative. Okay, so which 2 quadrants is sine negative in? The third and the fourth. So we need to think, what is my angle in the third quadrant that has a 6 in the bottom?
7 pi over 6.
And then what is the angle in my fourth quadrant that has a 6 in the bottom? 11 pi over 6. And so this time, for the full equation, we actually get 3 answers. 1 from our first factor and 2 from our second. Yes, only so. What questions do we have on that? Okay, so that's our quadratic type. Do I have a quadratic type on this one? No. But we still got a lot of trig stuff going on, right? So like right now, I can't just do my opposite operation because like I would want to subtract 4 cosine, but then we have like cosines on both sides, so that's not super helpful. So what is another method that we have for factoring though? So you want to factor out the cosine, because remember we call that our greatest common factor. Yeah, so remember one of our other methods is to factor out a common factor. And in this case, I have a common factor of cosine. And then we're left with a 5 sine of theta plus 4. Well, now that they're 2 separate factors, we're allowed to separate that into 2 separate equations. And then from there, we can use our opposite operations. Now on our first one, cosine's already solved for, yes? Is 0 on our unit circle? Yeah. Again, remember we are cosine and then sine, so we're looking for where our x value is going to be 0. Where will that be?
Pi over 2.
Huh?
Pi over 2.
And?
Pi over 2.
Yeah. Okay. Then on our second one, we need to subtract 4 and divide by 5. Now, is negative or even positive 4/5 on our unit circle? No. But is 4/5 in between negative, or negative 4/5 in between -1 and 1? Yeah. So remember that whenever we got something like, say, 2, right, we would get a domain error when we tried to solve for it, because it has to still be between -1 and 1. Well, -4/5 is between -1 and 1. So we're still going to get an answer here. It's just not going to be a very pretty answer. So remember that we can take sine inverse of both sides. And we do that because our sine inverse and our sine undo each other. So then we would want to plug that into our handy dandy calculator. So remember we click our little green second button, and then you click your sign, and then we type in -4/5. And what do we get? Okay, that's in degrees. If we are in radians, we get -0.927. Yes? Do those answers look different than the answers that I've been getting for stuff? What makes them look different? They're decimals, okay, which I said, because it's a 4/5 is not on my unit circle, that means we're not going to get super pretty answers. So that part's okay, we kind of thought that might happen. Is there anything else that's different about them?
There's no pi.
There's no pi, which again is because it's not on our unit circle. Anything else? They're negative. Have we had negative answers on any of our equations? No. We've written all of our answers in the first rotation. Yes? Which means we also want to write these in our first rotation. So how do I get, right now they're negative, which means I'm going which way? Well, we normally go counterclockwise, so we're going clockwise instead, right? So we want the same angle, but going the other way. How do we get that angle? Yep, we're going to add 360 or add 2 pi to our answer. Now, we are still going to get a not pretty answer, okay? Because again, when we have stuff on that's not on our unit circle, it just makes it to be where we don't get nice pretty answers. But we can at least make them positive, which is helpful. Okay. So here we actually get 4 answers. Or no, sorry. This is technically just 1 answer. So we get 2 answers from here, and then you could either write it in degrees or radians. Either one is fine. But we get 3 answers this time.
So how do you get the 306?
This one? So this was in degrees, so I added 360.
Okay.
This was in radians, so I added 2 pi. Either one would be fine. So it's just if you're in degrees, then add 360. If you're in radians, then add 2 pi. Because we want the positive answers. Other questions?